All right, today we are working on analyzing graphs and their relations. So now we're going to be looking at the graphs and we're going to figure out what the graphs actually mean. So let's get started. So let's start off with a problem. The first problem we're going to deal with here is stocks. An investor assessed the average daily value of a share of a certain stock over a 20-day period. The value of the stock can be approximated by this. Kind of a messy equation here. And notice, D is limited. It must be between 0 and 20, where D represents the day of the assessment. So D is my day, and V of D is my value of my stock. So use the graph to estimate the value of the stock on the 10th day. Confirm your estimate algebraically. Okay, so on day 10, I'm going to look up here and I have my value right there. So it's between 30 and 36, and I'm going to say it's about a third. So I'm going to estimate it to be 32. Okay, now to confirm the estimate algebraically, I'm going to write V of D over here because I need to do V of 10. V of 10 equals 0.002 D to the fourth minus 0.11 D to the third plus 1.77 D to the second minus 8.6 D plus 31. Whew, that's a long thing. And now I've got to plug 10 into that. Well, as I'm doing this, I'm going to multiply. So 10 to the 4, this is 1 with 4 zeros behind it. And so when I plug this in, it's going to move this decimal point over 4 places. So V of 10 will equal, I'll move this over 1, 2, 3, 4 places, and I'm going to get 20 minus. This will move the decimal 3 places because this is 1,000, 1 with 3 zeros. So when I move it over 3 places, I'll get 1, 1, 0. And then this one is going to move the decimal place over 2 places because this is 100 multiplied by 100. And I'm going to get plus 177. And this will move the decimal place over by 1 place because that's 10 minus 86 plus 31. So I'm going to start by adding up all of my positive values. 177 plus 31 is 208. Plus 20 will give me 228 minus. Okay, now I'm going to put my negatives together. So I've got 110 and 86, so that's 196. Now, for me in my head, I subtract this, and I actually subtract 200. This is 200 with 4 extra that had been taken away. So I need to take 200 away and then put those 4 back. So 228 minus 200 is 28. Plus 4 will give me 32. And notice my estimate was correct. All right. Now, there is a part B to this problem. All right, for part B, I'm trying to confirm what parts of this, or where in this graph the stock was valued at $30 per share. So, estimate the days. Looks like here it kind of was, but realize that 1 was in this spot. So it would really be here at 1. So even though it crosses 31 there, it's kind of just hopping to the next day. So that one I'm not going to count. Here it looks like in the center of a spot it was, and then here it looks like there was a day where it was 31. So here, this is at 9. And this one is at 13. So now I need to confirm my estimate algebraically. This means I need to find v of 9 and v of 13. Okay? So v of 9 and v of 13. Plug these into your calculator and you should see that you'll get the same answer. Because I have this on a PowerPoint, you'll never be able to see my calculator. But using the last one, you should see how I plugged it in. So go ahead and try these and confirm that this is where v of d would equal 30. All right, we also need to be able to find the domain and range using a graph. So in the last section, we talked a lot about domain and range and how it worked. In this, you will need to be able to give me the domain and range in both set builder and in interval notation. So let's go ahead and work through one of these problems. I'm going to start with domain, d equals, okay? The domain, I'm just looking at the x-axis. So I can see for all of this, x is defined. If you want to, you can imagine that this is smashed onto the x-axis, and everywhere where it's red, there would be line. Notice this circle. That means it cannot equal there. So I'm going to start in interval notation. This is -2. Consider where my things are. When I go 2 out, that's going to be 4. So this is -2. So I can be at -2. And I can go all the way to 6, but I can't equal it. That's the domain in interval notation. In set builder notation, I would say that this is x such that -2, and it's greater than or equal to x, and this is strictly less than 6, and x is an element of the real numbers. Okay? That's the set builder notation. For the range of this, I'm going to do the same thing I just did with domain, but I'm going to look at the y-axis. So let me change my color so that you can see it as I scribble on this again. So up here, I can see that it comes all the way up to 4, and it actually can equal 4. And it comes all the way down like this, all the way down to 0. And even though there's a circle here, I do have a dot here, and that allows me to equal 0. So in my range, I'm allowed to equal 0, and I'm allowed to equal 4. In set builder, so there's interval notation, set builder notation, x such that 0 is less than or equal to x is less than or equal to 4, and x is a real number. Okay, and close braces. Next problem here. I'm going to switch back to red so I can do my domain. So looking here at my domain, I see that I can't quite equal 4, so I'm going to put a parenthesis thing there. But then I'm allowed to equal all of this. I can equal it until I get to this point. And then I have a space like that again, where I can't equal. And it's on both sides. I can't exactly equal net 2. And then all of this is defined. And because of the arrow, it's going to keep going forever. So my domain equals, in interval notation, I need to say from -4 to 2, and then I need to do the union of 2 to infinity. Okay? In set builder, I would do the same thing. I'm going to say x such that -4 is less than x is less than 2, or x is greater than 2, And then I need to say x is a real number. All right. For the range, let me switch back to my green pen. The range, I'm looking at y. So up here, the only place I can be on this axis here is at that point. I can't go up and down from it. And then I can't equal -2, but I can be all of this up to -2 and down to infinity. All of this is allowed, but I can't equal. So I'm going to put my little parenthesis there. So my range will equal, in interval notation, I will have -infinity, because I start with the smallest, to -2, and I can't equal -2, union, and then I need to use braces to show that I'm only allowed to equal 6. Okay? In interval notation, I'm going to say x such that x equals 6, or x is less than, strictly less than -2. And x is a real number. All right, let's try another problem. Find the y-intercepts. We need to find these both graphically and algebraically. So looking at this graph, I can see that it's crossing at x right here, or crossing y right there. So graphically, I'm going to say that it's crossing at 4. So I'm going to say 0, 4. Now, if I look at the y-intercept, there are no other y-intercepts. So now I need to check here. I am looking for f of 0, because to cross y, x has to be 0. F of 0 equals 0 cubed plus 0 squared minus 6 times 0 plus 4. And all of this equals 4. So that is my y-intercept. Let's look at this one to find the y-intercept. The y-intercept here, it looks like it's crossing right there. So I can't see what it is, but it looks like it would be just under 3, maybe at 3. So I'm going to say 3 question mark, because I'm not sure what it is. It doesn't quite look right to be 3. So I need to plug x equals 0 in. So h of 0 equals, because at the y-intercept x is 0, square root of 0 squared plus 6. This equals the square root of 6. So my point, the answer for this question would be x at 0, y at square root 6. There's my answer. All right, so the next thing that we are going to do is actually find the roots, or the zeros, of a function. Now on this slide, I'm going to do A, and then I'm going to clear the slide and I'll do B. But looking at this, I have this function. And this function, we're going to approximate where it crosses x equals 0. Let me get my pen going again. So it looks like it's going to cross x equals 0 here, here, and here. So I am looking at this and I'm saying x will equal 0. Okay, when it's at 0, when it's at y equals 0. It looks like maybe here it will be x equals 1 and 1/3, maybe something like that. And here it looks like x equals 2. Okay, So let's go ahead and work through this problem algebraically. We now have what we graphically estimated. So algebraically, we need to solve this problem by factoring. 3x cubed minus 10x squared plus 8x. Well, from all of these, I see I can factor out an x. So I'm going to take the x out. 3x squared minus 10x plus 8. Well, this is a perfect time to show you how to factor using the AC method. So you see 3 and you see 8. Okay, so 3 times 8 is 24. Okay, 24. The factors of 24, I get 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's all. To add these up, I see that 4 and 6 add to make 10. So these make 10. So I'm going to rewrite the inside here. X, 3x squared. Now, 3 and 6 have a common factor, so I'm going to write 6 first. Minus 6x minus 4x. All I've done is I've split up this 10x into 6 and 4 plus 8. Now I'm going to factor. I'm going to find out the common factor here and the common factor here. X is still on the outside, and now I have 3x is a common factor, and inside I'm left with x minus 2. And then here I'm going to say minus 4, and I'm left with the inside x minus 2. Now, these match, so I can pull these factors together now, and I get x, 3x minus 4, x minus 2, and then this all has to equal 0 for this to be true. Well, I can look at this and I can say, well, then x equals 0. Ooh, it jumped on me. X minus 2 equals 0. That means x equals 2. And 3x minus 4 equals 0. That means 3x equals 4. That means x equals 4/3, which is 1 1/3. Oh my thing is not liking me right now. All right, here we have the 3 estimations that we found were all true. Okay, so that's how we did estimating it and algebraically finding the zeros. Let's try problem B. So now I've cleared the screen and we can look at B here. We have h of t is this. Well, when I look at this for x equals 0, I get just 1 point right there. So I need to find that kind of looks like maybe 1/4, maybe 1/3, something like that, and it's negative. I don't know. Maybe something like that. So I need to find when 0 equals the square root of 4t plus 1. Well, the first thing I need to do is square both sides. So I get 0 equals 4t plus 1. And then negative 1 equals 4t. And then t is going to equal negative 1/4. And there's my 0. Now, the last thing we're going to do today is talk about symmetry. There is symmetry around the x-axis, the y-axis, and the origin. Okay, so the x-axis means like the x-axis is my mirror, and you will find points on each side. The relationship here is really important as we start testing functions and we don't want to graph them. If you plug in x, you can get a positive and a negative y. Here, when it's symmetric about the y-axis, this is actually a function. So this is not a function. Okay, because I'm getting two different y's for the same x. Okay, but in trying this, if you replace y with negative y, you'll get the same equation. Okay, replacing x with negative x, you get the same equation. And here you replace both x and y. These relationships are very important, okay? Because when I'm doing this with you in just a second, I'm going to show you both looking at it and then plugging things in. You need to be able to plug in y with negative y and get the same, x with negative x get the same, and then plug them both in and get the same to talk about symmetry if you don't want to graph it. So let's go ahead and try a problem. Here's my first problem that I'm going to do. Looking at this, to me, I can say it looks like it's symmetric about the y-axis. This kind of looks like my mirror. So if that looks like my mirror, I'm going to be looking for a y-symmetry. For the symmetry about the y-axis, that means I need to plug in x with negative x. So I'm going to turn x's to negative x's and then try it. So y equals negative x squared plus 6. Y equals, well, negative x times negative x will give me a positive x squared, so I still have negative x squared plus 6. Well, this is the same as what I started with. So it is symmetric about the y-axis. Let me erase that. And we'll try this again. I need my pen back. Where'd you go? There you are. So we write symmetric I should have two M's there. You guys aren't here to help correct me. Symmetric about the y-axis. All right. Let's try another symmetry problem. Find the symmetry. Well, it looks like this could be a mirror, and it looks like this could be a mirror. Now, if it's the origin, then this is a mirror. And all three lines look like they could be mirrors. So I'm going to say it may be symmetric in all of them. So let's take a look here. Let's try y with negative y. Okay? Then I get x squared plus negative y squared equals 25. Then x squared plus, well, this square takes care of the negative, and I still get y squared equals 25. So that's true. X goes to negative x. For the same way, you're going to see negative x squared plus y squared equals 25. This square is going to take care of that negative sign, so I'm going to still end up with x squared plus y squared equals 25. And finally, if I replace both, so x goes to negative x and y goes to negative y, I'm going to get negative x squared plus negative y squared equals 25. And then both of these negatives will go away, and I'll still end up with x squared plus y squared equals 25. So this has all three kinds. Oof. This has all three symmetries. All right. From here, I want to leave you with one more note. I want to talk to you real quick about even and odd functions. Functions that are symmetric with the y-axis are called even. So you need to look at this symmetry to know if it's even or odd. Okay? If it's the origin, it's odd. If it's the y-axis, it's even. Remember that if it's symmetric about the x-axis, like this, then that is not a function. Oy. Okay? So we don't have to worry about symmetric about the x-axis. Okay? The y-axis is even. The origin is odd. Okay? Here are the tests. You can test the function in this manner. I am not going to test these functions here, and it's not on your homework this time, but I can say that knowing this, remembering this, can be useful for problems coming up. With that, this is the end of this video. Go ahead and work through the homework and let me know if you have any questions. Enjoy your weekend if you're not working ahead yet.